All right. Hello, class. I'm Nicholas Szostek.
And I'm Michael Paiva.
All right. And for our project, we decided that we will be making an ammeter for an automotive application. Most ammeters in today are all analog and they're not digital. So we decided that we wanted to build a ammeter that is more with today's standards. We propose that we can make an ammeter that will display the current drawn on an LED pixel display with a bar graph relating to the vehicle's current maximum output. We also propose that we can store current drawn for use in analytics to potentially alert of short circuits or damaging spikes of current drawn throughout the engine of said car that you would add this ammeter into. There are similar solutions for this problem, but they are very outdated. As I said before, they're mostly all analog and not digital in today's world. And we came up with this idea, and I'll let Michael explain that.
So I came up with this idea because I'm building a Jeep for off-road use. And I've seen, I've been off-roading my whole life. So I've seen people do this when they do off-roading and stuff like that. They either replace the alternator every time they go out or they carry an extra one with them. So that just in case something happens when you're out there, they can either fix it or hopefully it doesn't die. This is important to me because, like I said, I'll be building a Jeep and I hope to have it in there so that I can keep an eye on the alternator life and everything like that. And then beyond this course, we could expand this to monitor all the subsystems in the vehicle. Yeah. So that it monitors for any short circuits or any damage anywhere in the vehicle and could tell you immediately where the damage is.
Yeah, that would be cool if we continued on doing that. So for some of our marketing needs, we talked to some of our friends, our buddies that use, everybody uses cars. And we decided, and we looked on Amazon, most of these gauges are junk because they're just point needles and they use those old outdated type of coils that collects the data for the ammeter. For our marketing needs, we decided that it needs to be easy to use. We want to have a clear LED display instead of that old outdated analog pointer system. We wanted it to monitor accurately, so we knew exactly what was going on inside of said Jeep engine and or any car we put it into, and it needs to be able to connect to a phone so you can see all the data on a phone. The basic theory behind an ammeter is it's a device that will measure the strength of the current flowing in an electrical circuit while it's connected in a series relative to the circuit. That's the basic outline of how it works. It doesn't have to be inside of a car, but for our specific application, we are using the ammeter inside of the car. The basic math behind it is just Ohm's law. Everybody should know that. We can also use shunt resistors, as we showed inside of our progress report, to build multi-range ammeters, which we could always use in our project. Maybe we don't know yet. We haven't gotten to that stage. It's currently being done, as we said, the old school ways with the analog and the PMMCs, which is mostly outdated and needs to be updated, which is what we intend to do with our project. There's a few ammeters on the market that have LED displays, but they're still outdated and use the old technology that isn't very accurate when they measure. And that's pretty much what the limitations of the current designs are. The only similarities and that would be with our concept and the current systems is basically the basic structure of how an ammeter works. But we basically want to change everything by using non-volatile memory and the LED display to update it to the 21st century, I suppose. And Michael will talk about the need, the objective, and the background for our project.
Okay, can we display the ranking of needs?
Oh, yes. Let me share my screen. Oh, did I go to the wrong screen? Oops. Let me just. There we go. Do you see it?
No, I see a X-wing.
Oh. Now do you see it?
Yes, thank you. Okay, so in this ranking of needs, book wasn't really clear on how to do this. So how I've done it in the past is if the row on the left is less important than the one at the top, it's a 0. If it's more important, it's a 1. Then you just add up the score on the right. So you can see the most important part of our project is it needs to measure accurately. And then there's a followed by the LED display and ease of use. And then connect to the Bluetooth device is the least important for us. And then can you go up to the objective tree?
Yes.
So this just shows a breakdown of all of our different objectives. And if you add across the top, it adds up to 1. And I just went by the needs ranked. And so I just kind of broke them into what was most important and what was least important. And then underneath each objective, those objectives add up to 1 as well. And it's the same style, just use the weight from the ranking of needs. And then the last part, so I'm sorry, what am I talking about now?
The needs, the objective, and the background. If you just want to kind of go over it, just like verbatim of what it is. I can stop screen sharing if you want me to.
Yeah. Okay, so the background, like Nick said, all the current ammeters are analog, very difficult to read while traveling at speed, and don't make a whole lot of sense to anyone that's not an electrical engineer, unless you're constantly paying attention to it. You'll miss damaging spikes of current or anything like that. Our project will store all of that data so you can monitor it later, check to make sure that you haven't overtaxed your system or anything like that. And I think that's probably it, right?
Yeah, sounds good to me. All right, and that is our project for our capstone class. Thank you.